Welcome to the video on graphing tangent parent functions. So with this video, just a really quick spoiler alert, your graphs are going to look like this. All right, so this whole video is going to end up with us finding out that the graphs look like this. I just wanted to put this ahead of time though, because I want to analyze what different ways that you can try to make yourself draw this a little better. If you notice, this looks a little different than sine and cosine in that we have two vertical asymptotes. And then we have the graph that's actually between those two asymptotes. Now, this graph right here, it kind of looks like a cubic function that's squished between two asymptotes, okay? And then it just repeats itself over and over again. So it's still a periodic function. It's just not going in that kind of wavy fashion that we saw with sine and cosine. This thing has some asymptotes in it. And again, just draw it like it's a cubic that's stuck between two things like that, all right? Now, this video is going to go over three different things. I'm going to show you how tangent is actually built from sine and cosine. I'm going to show you the connection between the graph of tangent and the unit circle. And then I'm going to summarize it all in the quick steps to graphing. So if you want to skip ahead to the quick steps to graphing, that's the kind of meat and potatoes of this video. It'll show you how to actually do it. These two things show you where it comes from, which is very good to know, only because it kind of connects with other things. But if you just want to kind of get to how do you do this, go ahead and skip ahead to this part. Okay. If you're looking at this on YouTube, just look below on the description section. They'll have little bookmarkers so you can skip between those different parts. All right, so starting off with building tangent from sine and cosine. Now, we know the unit circle. Hopefully you've memorized it. If not, hopefully you have it nice and handy, that you can reference it pretty fast. We learned that with sine and cosine, or cosine and sine, that matches up with the x and y coordinates of all of these points that go around the circle. So if I asked you for cosine of 60, you would go to 60 degrees, you'd go to cosine and say, okay, that's the x value of 1/2, so cosine of 60 is 1/2. Or if I said, find sine of 210, you'd go around to 210 degrees, or 7 pi over 6, and say, okay, well, sine is my y value, so that's negative 1/2 is the value of sine of 210 degrees, or sine of 7 pi over 6, right? Now, that's kind of leaving out tangent, right? We haven't done anything with tangent. We got to figure out, okay, well, how is a unit circle related to tangent? Now, turns out tangent can be built from sine and cosine, and let's figure out how that works. If I told you, now I'm showing this proof kind of backwards, but if I told you to think about sine and cosine as a fraction, so if you just put sine over cosine, and I'm kind of leaving off the angle that's supposed to come after, but if I thought of sine, sine is opposite over hypotenuse, okay? So if I thought sine over cosine, sine is opposite of hypotenuse, which means cosine is adjacent over hypotenuse. Now, if I do a little bit of algebraic gymnastics here, I can actually turn this thing into tangent, okay? Remember, tangent is just opposite over adjacent. Now, first thing I'm going to do is I'm going to make it into something a little bit more familiar. This is a whole bunch of fraction bars going on. Now, if you think about a fraction bar, it means the same thing as division. So I'm going to turn this middle fraction bar into a division sign. That way I have the top divided by the bottom. This says the top divided by the bottom. This still says the top divided by the bottom. Okay? So if I remember correctly, as far as division by a fraction, that is the same thing as multiplying by its reciprocal. So this is the same thing as this, okay? Now, I can see that I have a hypotenuse on the numerator and a hypotenuse in the denominator, and I'm multiplying. So what's going to happen when you have something exactly the same on top and bottom? It goes away, or it makes a fancy one, so it doesn't really affect it at all. So I got opposite over adjacent. So sine over cosine simplifies down to opposite over adjacent, which is tangent. So now I got tangent. Now that I have tangent, I know that sine over cosine becomes opposite over adjacent, which is tangent, which means that tangent is sine over cosine. That's the transitive property from geometry coming back to you. So tangent is sine over cosine. Now, so what? The reason why we did that was because now when we look at the unit circle, we can actually use the unit circle to figure out tangent values as well. Because since sine is y and cosine is x, I know that tangent values are just going to be my y values over my x values. So if I wanted tangent of 30 degrees, I would put 1/2 over square root of 3 over 2, which is a horrible number, but yeah, actually that's not that bad. And that's how we would figure out tangent values. You just put these points, the y values over the x values. So that's the first part, 5 minutes in. Like I said, you can skip to the end if you want to. Connecting the graph to the unit circle. So now that we know tangent theta is y over x, we can use that to figure out tangent values all across this whole thing, which helps because when we start making our table, we have to figure out tangent pretty fast. Now, we don't need all of these points. We just need enough that we can see a pattern. Just like before, we could use all of them, but we're not going to. Now, the easiest points to work with are these ones and zeros because putting y's over x's and you just got ones and zeros, that's pretty easy. Also, these ones right here, these are pretty easy as well because you have the exact same values for your x and your y. So if you have something over the exact same thing, you're going to get a 1. So that's pretty easy as well. So if you go through this unit circle, you're going to find out that all of those red lines I just put in, those are all the easiest points for us to find our tangent values of. So that's the parts we're going to focus in on. So I'm going to clear all these other parts off and kind of make it bigger so that we can see it. All right, so now we're going to use our unit circle. Like I said, you should have it handy and start filling in a table. For your homework tonight, you're going to have to fill in a table, so make sure that you have it handy and you can go around it as many times as you need to, okay? I'm going to put a little graph up here. That's going to show what the graph should look like when we're done. I'm going to label off my x and y values here, so it's easier for us to kind of see. Now, unlike sine and cosine, with sine and cosine, I started at 0 and I worked my way across the positive axis. And then I said, you can go this way as well. But with our tangent, we actually want to go both ways with this. We want to go towards the positive side and the negative side because if you look at this tangent curve, it's going on both sides of 0. So I'm going to start my graph or my table off at 0. So if I look at 0, 0 point is right here. It's 1, 0, so xy. So I'm going to put y over x. So y is 0, x is 1, so 0 over 1. So tangent of 0 is going to be 0 over 1, which is 0. So tangent of 0 is 0. So my first point is 0, 0. So if I was graphing this from scratch, and like I said, I'm leaving this graph up here, I would put a point at 0, 0, right? Now we're going to move to our next point, our next interval. So the next interval we want to go by is pi over 4s because, like I said, that's the easiest part to use of the unit circle. So we're going to go to pi over 4 next. Come on, yellow blocks. Okay, so pi over 4. And now we're going to put our y over our x. Now this looks kind of funky. I'm going to put square root of 2 over 2 over square root of 2 over 2. Square root of 2 over 2 over square root of 2 over 2. Now just keep in mind, this numerator is the exact same thing as this denominator. So if you have something over something else that's the same thing, you get a 1. That's why we picked that, because it's an easy point to plot. So pi over 4 comma 1, that's going to be about right there. I don't have these markings on here, so we'll just kind of guesstimate. So there you go. Now, if you look at our next part, our next interval is pi over 2. So pi over 2 is 0, 1. So I'm going to put my y value over my x value, so 1 over 0. 1 over 0, you're not allowed to divide by 0. So 1 over 0 is just undefined. That is how we get this asymptote right here at pi over 2 because the point ends up being undefined, so I need a vertical asymptote there. All right. So that takes care of this part. Now you could very well keep going around the circle to 3 pi over 4 and keep doing that. But the thing is, that's going to start up basically another cycle over here. I want to be able to work backwards. So I want to go backwards this way. So while I was going, was this counterclockwise for my positive values? So I started at 0, went counterclockwise. I'm going to go clockwise to get my negative values. All right. So starting back at 0, I'm going to switch now to going this way. So I'm going to come down this way, 7 pi over 4. Only problem is that's not a negative. If I was on my x-axis and I went to positive 7 pi over 4, I am getting points on this side of the graph. I just said I want to go to the left. So the unit circle is kind of interesting in that way, because if you go this way, so if I go counterclockwise and I get to here, 7 pi over 4, that's the exact same thing as me starting here and going down this way to here. you end up in the same spot. It's just it was a lot shorter distance. Um, Now, in order to turn it negative, though, if you think of positive going this way, negative is going down. Positive is going up or counterclockwise. Negative is going down or clockwise. So the distance from here to here is pi over 4, which means that if I go in the opposite directions, the exact same distance, that's just going to be a negative pi over 4. So while I go this way, it's positive pi over 4. This way is negative pi over 4. So 7 pi over 4 is the exact same thing as negative pi over 4. All right. And then that will be going this way. So pi over 4 is this way, negative pi over 4 is this way. Same point right here. So I'm going to put my y over my x, and then I'll just get a -1. All right. Now, if that kind of threw you off, let me go and plot this real quick. If that kind of threw you off, don't worry too much about it. The main thing is us getting these points. All right. If you have to memorize it, and it's not a very hard thing to memorize, feel free to. This is just showing where it came from. Okay. So just know that the direction will imply negatives. So while this was positive pi over 4, coming back this way, it's negative pi over 4. All right, so we're going to switch now to our next point, which is down here, 3 pi over 2, but the same kind of logic that I just did. So if I went this way, positive pi over 4, going this way is a negative pi over 4, going this way is a positive pi over 2, so going this way is a negative pi over 2. And if you look at it this way, that's like a 90-degree angle, gets us up to there. So a negative 90-degree angle gets us down to here. So a negative pi over 2 will get us down here, okay? All right, so using this point, we're going to do -1 over 0. And it doesn't matter if it's positive or negative. If it's over 0, it's still going to be undefined. And that gets us this part over here, okay? Just to clear that off and kind of see the part that we built, you will see this when you're plotting. Basically, you just got to make sure that don't connect this with a straight line, even though these points line up in a straight line. You got to curve it because you cannot go past this asymptote. So curve it up and curve it down, all right? And that is a connection to the unit circle as far as making tables goes. Okay. Now this screen I keep coming back to. If you need to know like what exactly do you need to take notes on, this is probably a good screen to do once it's all finished and filled out. Last one is quick steps to graphing. So this is the part where I told you, hey, if you want to skip ahead and figure out how to do this pretty fast, this is where you go to. All right. So here's quick steps to graphing the parent function. It's going to be altered a little bit when we get into the transformations, right? So the first step is to mark your intervals. So make sure you go to the left and to the right. You're going to plot your what we're going to call it a center, and then you're going to follow the pattern. You're going to work from the center out, and I'll show you what I mean by that right now. So first off, you're going to get a point right in the middle. You're going to go to the right and then go up one, and you're going to the left and go down one. It's almost like these 3 points make a straight line. They should be lined up like this, okay? Next up, you got your asymptotes. One's on the outside there, one's on the outside there. So you work from your center, you go to the right, goes up one, to the left goes down one, and then you just kind of cap it off with asymptotes on both sides. And then just draw it, okay? Draw like a cubic function that's stuck between those two things, right? And then that's basically it for the parent function. So on your homework, you are going to get a table that you're going to have to fill out. Again, I only filled out up to pi over 2 and negative pi over 2. I'm going to want you to keep going with that, though, so just make sure you can do that. But yeah, so let me show you what this looks like with all three of these representations. So we're going to have a graph, we're going to have a table, and we're having this kind of pattern thing going on here, right? So first off, make sure you mark off your intervals. So I can see my intervals from 0, pi over 4, pi over 2, 0, pi over 4, pi over 2, and then negative pi over 4, negative pi over 2. I'm going to mark off my y values. It really only goes up to 1 and -1, but I had extra lines, so I just fill them in, basically. All right, so let's start at our center. Center is 0. Okay, so 0, 0 on our table. That's our center on our pattern, and then plot that 0, 0. Next up, we're going to go to the right and to the left. We're going to go right one interval and to the left one interval. So that's just our markings. So remember, when you go to the right, it's going up one. You go to the left, it goes down one. And that's shown here, okay? So to the right goes up one, the left goes down one. So I went up to +1, down to -1, basically up one, down one. What that looks like here is just these 2 points. Okay, now you got your triple point. Triple points are in a straight line, looking good. And then our last parts are asymptotes. So just go out to the asymptotes, and then that's basically at our next interval, which is right here. Just draw a couple of vertical asymptotes right there and right there. And that's basically the framework. Now you're just going to fill it in with your cubic looking graph. It's not a cubic, but it's cubic looking. Okay. And that is one cycle, because after that, it's going to repeat. You just do another triple dot and then draw it. I didn't put enough cells here to get another asymptote on there, because this is asymptote, triple dot, and then another asymptote. I can fit the triple dot, so there you go. Okay, so if you want to draw another one, you would just do another triple dot, draw up and down. Same thing here. You would just do another triple dot, go up and down. And again, I didn't have enough room for my asymptotes at the end, but basically this would be almost 3 cycles. Okay. Um, if you have any questions, feel free to email me or come in during my office hours. All right. Take care. Bye bye.